Okay, very cool. Thank you, everybody. Thank you for the introduction. My name is Jevgeni Kabanov, but you can also call me JK. I'm the president of Bolt. If you haven't heard about Bolt, go outside and watch for green things. Everything green is basically us. And if you haven't heard, if you don't know what's a president, it's like the CEO, but without any of the credit or the glory. And today I'm going to talk about, how Bolt implemented AI. And when I'm going to talk about AI, I'm going to be more or less today speaking mostly about the same thing that previous speakers spoke about, which is the large language models, ChatGPT, Gemini, the whole shebang. They say start with a joke. So I had ChatGPT write me a joke. So why did the chicken cross the road? Because the probability of having a good time was higher on the other side. Not terribly funny, is it? And this is very illustrative of what I want to talk about, right? The hype is huge. Well, it's a little come down a little bit. We're not every day talking about how AI will destroy the world. We're not talking about human level or godlike intelligence within like 18 months. But there's still a lot of hype. We still see a lot of very cool demos doing very cool things. We still kind of talk about that, we will replace, like AI pundits still talk about replacing doctors and lawyers and software engineers and hopefully soon executives. But reality is a little bit different, right? So reality in the wild is more like this. So AI, the thing about AI is that people tend to humanize, or using more correct English term, anthropomorphize AI, right? So we think about them as if we think about a human. We think about AI as if it's smart or stupid, intelligent or unintelligent. The problem is it's none of those things. It's just weird, right? So because we tend to think about it as a human, we kind of get stumped when it does like really, really stupid things. But the problem with AI is exactly that it's counterintuitive, and large language models. It's not smart, it's not stupid, it's fit for some tasks, it's not fit for some tasks, it's often counterintuitive. And this is what I want to talk about today, like how to engage with that weirdness, how to take that weird entity, which is sometimes does really surprising things, and make it actually do useful stuff. And generally, if I talk about AI at Bolt, we do a lot of things. We have, I think, some 100 different machine learning models deployed in production, ranging from across really different tasks, like dispatching, mapping, matching, computer vision, OCR. But the most interesting for this is the customer support case, right? So we have a customer support bot called Alfred. If you take a scooter and then afterwards something doesn't work and you complain to support, Alfred is probably going to answer you, right? If you order something from Bolt Food and the dish arrives wrong and you contact support, you probably contact Alfred. It's still A/B tested, so you might also not contact Alfred, but the probability is high that you will. And so why is that so important for us? Well, Bolt is big, right? Bolt is really big. So our budget for customer support is bigger than most companies. And not as big as Google, but we're getting up there. And we have about 2.5 million tickets per month. And obviously, the opportunity is huge. And we're a very operationally focused company. We're all about efficiency. So we have started automating a long time ago. But historically, we started automating with a rule engine. So basically, when the customer support issue would come in, we would match the category, we would try extract the data or ask the customer for specific data, we would have a policy, it would match, and it would do something, right? And there was like quite a few cases that could be solved like that. We got up to 15% of our customer support volume was automated through this rule-based engine. But it's also slow. Like every new use case needed like custom implementation. And it's also like dealt very poorly with any kind of a weird customer request, right? Even a change in wording. And so obviously, when ChatGPT happened, especially when the GPT-4 came out, then we got really interested because it's the most obvious use case. And so we decided to apply ChatGPT for this support. And our first, this is kind of a long journey getting there. So it's not it's not as straightforward as you think. So there we go. So the straightforward idea, which we had initially, was actually, you know what? They say GPT-4 is so smart. Let's just take our whole policy. Let's feed it the customer text. Let's feed it the order data, and let's see what happens. What happens is it's really, really stupid. It doesn't at all, cannot engage with like kind of big instructions. So that did not work at all. Our second approach was, okay, let's pull the policy per category. So for example, I don't know, the food is cold in Bolt Food. We had the specific policy. We already had it because obviously we have 2,000 customer support agents, so they also don't invent it, right? They read the policy, they're trained by the policy, so we already had the policies. So what we basically separated the policies by the issue, and then if the food was cold, then like the policy would say something like, hey, if the order was more than 30 minutes late, refund the order. Or maybe it would say something like, if the order is 30 minutes late and the restaurant didn't cook the order too early, then refund the order. Otherwise, refund the order but charge it to the restaurant, right? Something like that. So it could get more complex than that. And so what we do, we would basically pull that specific policy for that specific issue, and we would feed it to GPT-4. And then the job of GPT-4 was basically, from one point, interact with the customer, but from other point, interact with the backend, right? So it would have to say to the customer, I'm going to refund the order, but then it would also have to say, issue the JSON to the backend and say like, hey, order number like this, customer that, refund, like blah, blah, blah. So basically structured response to the backend, free like English response or whatever language, multilingual response to the customer. And that's what we started from. And that was very interesting because already that kind of worked, but not really. So initial solutions worked less than 50% of the time. So then we started doing several things. One is just we started feeding it more context. Our starting prompt for ChatGPT, for GPT-4, was about 1,000 tokens. And then we gave it more information about the order, more information about the customer, more detailed policies, and then it was 2,500 tokens. So actually, one order, I think handling one support case costs right now us 8 cents, which is great because handling support with a human costs us like a few euros. So it was, okay, so we got, by feeding it more context, by tweaking the prompts, by giving it more data, but still very specific instructions, we got to success rate above 50%. The next step was actually filtering it down. So we also developed an in-house model. So basically did our own machine learning model and trained it to narrow the solution space. So let's say, because our policies, they basically differ by country, they differ by product, they differ by customer case, but they still can be quite broad because they're meant to be interpreted by humans. And so it might say something like, like I said, for cold food, there might be a few conditions, like if this, then that, if this, then that. And and there could be a couple of pages of policies in the end. So what we did, we trained a in-house model that would take the current order, and then narrow the solution base, make one suggestion, what is the most likely answer, or maybe make a couple suggestions. And that actually significantly increased success, right? And it's quite interesting, because what you need to realize is specialized models still outperform generalized models. Like with all the hype that LLMs get, a specialized model trained on your data with your inputs, with your outputs, will outperform an LLM for the task that it's created for, right? For a more narrow task, it's almost always better. And so we actually ended up combining GPT-4 with several models. I will talk about those. So this was the initial approach. But then we started iterating on more specific problems. The first problem is actually super interesting. The first issue we had is over-refunding. So I think the engineers at OpenAI has invested an enormous amount of time to make sure that GPT-4 model, that the models, the LLM models, appear polite and helpful, right? Because let's face it, they were trained on the internet data. You know, it included all of Reddit. So the most likely initial answer from an LLM trained on Reddit, when you ask it like, hey, my food is cold, can you help me? It would be, buzz off, I'm busy, right? So there's been an enormous amount of time spent making sure it's polite, it's helpful, you know, and it tries to solve your problem. And I think, like actually, the previous speaker was talking about fine-tuning, and that's exactly what fine-tuning is all about. If you take the model pre-fine-tuning, it kind of will give you quite random answers, and then after fine-tuning, where you say, hey, basically give it examples of very polite and nice and helpful answers, that's where it kind of gets polite and nice and helpful, because it will mimic that. And so the issue with GPT was that it was trying to solve the issue at all cost. And usually that cost was to the company. So it would, you know, like if somebody is unhappy and says, well, you know what, I received my order, but one item is damaged. Here's all the money in the world. In fact, it actually was even initially quite hard to get it to even limit itself to the amount in the order. Like, so the order would be like 15 euros, it would be, here's 80 euros. Come on. Like, so it does, you know, and this is again, you know, it's not smart. It kind of follows instructions, but not always, right? It wasn't an easy way to just kind of embed all the specific logic. So what we ended up doing is literally letting it solve things, but then if it does something strange, if it doesn't fit our policies, we just escalate to a human, right? And so like in most cases it was okay. It actually, in a lot of cases, it does perform quite well, but then we implemented some hard stops that, for example, if the category, like an easy hard stop would be if the category of the issue is that I had a missing item in my order, or I had a damaged item, then you shouldn't refund the whole order, right? So the refund has to be smaller than the order. So if the refund is like too big, then you can promptly escalate. And then we actually also trained an internal model, which would kind of also cross-verify that and also make suggestions about the refund rate and so on. So again, we used a specialized model to augment the generic model, because generic model is weird, again. And so that's kind of the way to address this one. Then the next problem is something that has been written a lot in the media, hallucinations, or just incorrect information. The problem is that GPT, like large language models, do not know how to say, I don't know. There is nothing like that. So if they don't know, they invent. And it's actually, you know, it's quite problematic, because this was an example early on the slide where Air Canada bot promised something, and then Air Canada had to deliver on that, because essentially, as a human, you don't know that you interacted with an AI bot, which you shouldn't trust. You're interacting with Air Canada support, and same here. You interacted with Bolt support. If Bolt support tells you that you can take your car to Warsaw, then you have no reason to believe that you can't. And then if later, you know, we try to fine you for doing something bad, and you're like, but look, here's a screenshot. I was told that I can do it, then it's on us, right? And this is kind of really hard to detect. But there is a way to approach it, and it's been mentioned again today, retrieval augmented generation. What that actually means in plain terms is we actually have the same problem with people. People also, like our customer support agents, they also will often say things that are not true, or at least sometimes will say things that are not true. And the way we approach it is we have trainings, we have knowledge bases. So basically, luckily, they usually know how to say, I don't know. So they go to a knowledge base, or hopefully they go to a knowledge base. They often do also pretty weird things. But we do have knowledge bases which describe basically everything is possible, everything that is true, everything that is possible. And so the way to help with this case is really that we, again, build another little model, or use a ready one, whenever we have this support case coming in, it extracts the topics, it extracts the keywords, and it searches our knowledge base for data about it, and then pulls it in and feeds it to the GPT-4, right? So now it has, and by the way, if you want to see it in action, I think a really nice place is to go into the Bing app and look at Copilot. So they've implemented it very nicely. Google has kind of also okay, but I think Bing implemented it better. Because what Bing will do, it will search the web. Like you ask it like, hey, I'm coming to Riga for 1 day, make me a cool itinerary. So Bing will first search like kind of websites about, hey, cool things to do in Riga, then pull them, and only then we'll start generating an answer. And then the answer will include links to the actual like websites and the actual data. So it will likely not invent stuff, right? And the whole idea is that when the model trained, you create parametric memory, and then what you feed is kind of external memory, and this shit actually works. So the same way, we want to improve this by feeding it data from the knowledge base, so it would make less stupid mistakes. And then the third one, and kind of the weirdest one, and actually we still don't know what to do with this one, is false promises. So it's kind of similar to hallucinations, but it's kind of like, it's down to the complete lack of self-awareness that AI has, right? AI doesn't know what it can do, what it doesn't do. It just knows what was in the data. And if in the data that it's trained for, when it's asked about, I don't know, like we have one example here on the slides, but for me, even more relevant example is when I once tried to cancel an order in Bolt Food, and I write to the support, and Alfred very happily tells me, it's no problem, I'm going to contact the restaurant. So it cannot contact the restaurant, but it doesn't know it, right? So that's the problem of false promises. I'm like, okay, my order is canceled. Fuck yeah, now, like it's great, and and then later the courier knocks on the door, and I'm like, what the hell are you doing here? The order is you get the point. And this one is still very hard to solve, right? And it's also very hard to detect. Because, again, the AI very confidently declares that it's going to do something which it cannot. We're still working with OpenAI. After at least the previous two issues, we now have, I think, about 2% of those weird cases out, like 98% that either solves well or they get auto-escalated. 2% is problematic. So you would think that this is quite bad, but actually with human beings, the rate is kind of similar. So the one thing you always have to remember is that it doesn't have to be perfect. It's just have to be not worse than people. Anyway. And this is, we have it in production. It's going okay. It's staged rollout, so obviously, it's risky. But by today, we already doubled automation from 15 to 30%, which, 15% of automation for us is like 9 million, so not so little. And this year, we intend to bring it up to 60 to 80%. So we kind of scaling it. And for the use cases that are covered, we have this 50, 70% reduction in tickets. So overall, as we improve on everything, we expect to have 60 to 80% automation. And obviously, there's a lot of cost savings and productivity gains. But I think even more interesting, a kind of an interesting effect is that we'll still have a customer support team after that. But now they're dealing with interesting cases. All the really boring, kind of trivial and meaningless stuff is now covered by automation. And now the customer support will deal with safety issues. They'll deal with people getting lost somewhere. They'll deal with things that involves the real world, which involves complexity. So that kind of comes to my wrap-up thesis is that, one, AI will have significant benefits for a business. And here again, I mean more the LLMs, definitely, right? So there's a lot of things you can do, but it's hard, it's weird, it takes a lot of work, right? And you have to be careful with it, and it is counterintuitive. And secondly, despite all the talk about AI replacing doctors, lawyers, software engineers, it's definitely not there. Maybe it's very hard to predict the future. Maybe GPT-5 or GPT-10 or whatever will replace executives and I can finally retire. But until that day, today we're talking about augmenting people. Today we're talking about the continuation of the journey that started with computers, with internet. Now we have AI. We finding new ways to augment the human mind. We're finding new ways to do exciting things, to raise our creativity, to raise our ability to do kind of cool stuff, to raise our productivity. And AI is great for that. And so I personally so far see kind of a brighter future where we're going to be doing more interesting stuff. Thank you. All right.